Here, we have a conducting rod in a uniform magnetic field. We are going to examine what happens when this rod becomes part of a circuit which contains a light bulb and starts to move. However, before we arrive at that point, it might be a good idea to review what happens when this conducting rod starts to move in the uniform field even before it is connected to an external circuit. The negative electrical charges on a conductor are free to move about the surface of the conductor. This is important because as the rod begins to move in the magnetic field, all the charges in the conductor will feel a magnetic force on them, but only the electrons are mobile. As a result, the negative charges will move to one end of the rod, leaving a net positive charge at the other end. The conducting rod in the uniform magnetic field is now connected to conducting rails and a light bulb to form an electrical circuit. If the rod is stationary, no force acts on the charges within the rod and the bulb is unlit. Once the rod starts to move with speed v to the right, the positive charges will accumulate at one end of the rod because the negative charges will move to the other end. This will produce an induced EMF. This induced EMF is called a motional EMF because it is only produced if the rod is moving. This EMF will then produce a current in the circuit and the light bulb will light up. As long as the conducting rod moves with a constant velocity, the light bulb will remain lit and its brightness will be constant. Increasing the speed of the rod will cause the motional EMF to increase, resulting in more current to flow through the circuit with an increase in the brightness of the bulb. Decreasing the speed will have the opposite effect, since the motional EMF will decrease, resulting in less current to flow through the circuit and thus decreasing the brightness of the bulb.